start a new unit talking about, not a new unit, we're just talking about proving triangles are congruent. Different concept than what we talked about in the past. Last time we talked about if you wanted to prove triangles were congruent, you basically have to prove that all 6 parts of this triangle were congruent to all 6 corresponding parts of this triangle. So the 3 angles and the 3 sides. Everything would need to be congruent to prove the 2 triangles congruent. Today what we're looking at shortcuts, and that's basically what they are. They are shortcuts. One of them is side, 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 one side, angle side, and one is hypotenuse leg. So those are the 3 shortcuts we're looking at today in order to prove that triangles are congruent. Okay, so we're going to use the side lengths and angle measurements to prove triangles congruent. The first one here is just side, side, side. It's really straightforward. It says if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. So when we talk about this, we'll talk about, well, here's a side. If we talk about AB right here being congruent to, SR, that's one side of one triangle and the corresponding side of the other triangle. There's a second side and a third side. And we can then say this statement down here, which is a very, very specific statement. Remember, this statement itself means that segment AB is going to be congruent to segment RS. It means that angle C is going to be congruent to angle T. It means that segment ST will be congruent to segment BC. Remember, that's a very loaded statement, so we need to make sure that when we write it in the correct order. Okay? Side, 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 basically all it means, if you prove all 3 of these sides, here's all 3 of these sides, 2 triangles are congruent. Okay? Some example of this is they'll give you a statement, they'll give you a picture, and they'll say, decide whether the congruent statement is true. Okay? Explain your reasoning. 2 things can go on. Either there's not going to be enough information to show that all 3 sides are congruent to all the other 3 sides, or another way that it could be false is somehow they'll mix around these letters. Okay, so they could mix them up on us, and we'll have to kind of check that as we go along. So to start off with, we do have one side congruent to another side. That's AD, and that's CB, so that's okay with me. Secondly, we have AB, which is the first side, congruent to CD, which is the second side. And then we could probably prove that this third side here is congruent to itself by the reflexive property of congruence. Okay? So then we say, well, these 2 triangles are congruent. Let's just see if they wrote it in the right order. When we start with ABD, that starts here at A to B to D. It crosses the 2 tick mark and then 3 tick marks. So we'll just make sure when we talk about the other triangle, it also crosses 2 tick marks and then 3. So CDB starts at C, goes to D, goes up through B. It does look like those 2 are congruent, so we'll say either yes or it's true, something like that. Is that okay? Okay. Second triangle, we'll do the same thing basically. This is the reflexive property of congruence. So these 2 triangles are congruent. Let's just make sure they did it in the right order. Triangle RST, so R to S to T. So it goes over 2 tick marks and then 1. RQT, 2 tick marks and then 1. Yeah, I'd say that's totally fine as well. Okay. The third one, should we just say it's no just because? Yeah, that's not going to work. Triangle ABC congruent to triangle DEF. Where they say this is ABC, so that's 3, then 2. Then DEF looks good to me. This is yes. Someone tell me a way that we could write this. Triangle ABC is congruent to some other triangle. That would be false. Someone tell me what we would do in order to get like a no or a false statement on this. Yeah. Tell me. Triangle FDE. Okay, and why is that wrong?
Because the letters won't match up. Like the segments will be different.
Okay, so FD would have to be associated with AC, and that's obviously not what's going on in our picture, right? Okay, so it'd be, there's a false statement, or if it gave us that, we would have to say no on it, something like that. And there's a couple other combinations we could use for that as well. All right, any questions on that? Okay. Next is kind of a weird deal. It says use the given coordinates to determine that triangle ABC is congruent to DEF. Okay? Some people would really like to, well, I don't know where I was going with that. Some people would really like to go through and just like plot these points. That works for some people. Other people would like to go through and just find some distances. We're trying to compare side lengths. So basically what we would do is we try to compare AB, and we'll find the distance of that. And we'll compare that to DE, we'll try to find the distance of that. So let's do that really quickly. We'll compare those and we'll talk about that in a second. So AB, remember that you're going to say let's see, 4 minus 1, we'll square that. We'll add that negative 3 minus 2, we'll square that. This would be, let's see, 3 squared plus negative 5 squared. That's 9 plus 25. So we're working with a square root of 34. Okay, that's what our answer turns out to be for AB. For DE, excuse me, for DE, we would say something like, let's see, 7 minus 4 squared plus 2 minus 7 squared. Something like that. That would give us the square root of, this is 3 squared plus negative 5 squared. It's actually the same numbers we just dealt with. So it's 9 plus 25. Well, that's the square root of 34. So again, it's using the distance formula. Are these two equal?
Yes.
Yeah, so we have basically one set of sides that are congruent. Okay? Can we just say yes then? Are we good?
No.
No, what do we have to do after that? So we basically go BC, and we're going to try to compare that to over here, maybe like EF. And then are we done? Let's just say that we have the square root of, I don't know, 29 equals the square root of 29. Are we done then? No, then what do we have to do? Okay, so we compare AC, we'll say that's, I don't know, the square root of, oh, let's get rid of the square root. So let's just say it's some nice number like 6. Then we'll say that has to be compared to DF. We'll say that's 6. Now can we say these two triangles are congruent? Yeah. Okay. So really you're doing the distance formula 6 times, which is a little ridiculous. What happens if instead this was the square root of 291 compared to the square root of 29?
Wrong.
Well, probably you did something wrong, or the two triangles aren't congruent. Okay? And we would just sort of stop there. Would you have to do these down here? No. If you ever get some that don't match up, just stop and say no, or just say it can't be done, or whatever it might be. Is that okay?
Yeah, but there are probably those people that will do it on the last one.
Okay. Write a proof. Okay? I'm going to focus a lot on proofs over the next couple of days just to make sure that we feel good about this. Generally speaking, these proofs aren't going to be that difficult, generally speaking. And I hope that you're going to see enough of these that you'll feel comfortable with them. Otherwise, you can always check these out online, or you might be doing that right now. Who knows? We'll start off with the given information. We'll basically say that KL, that segment, is going to be congruent to segment. It's already marked on the diagram, otherwise I would. So this is KL congruent to LN. And our reason for that is just given. Our second step will be our second piece of given. Segment KM is congruent to NM. Okay, we'll mark that on the diagram. That's this one here, congruent to this one here. That is also given. And what this does, maybe it's kind of nice to kind of look at what we're looking at. We've talked about this is going to be one side length. This is like another side length. So really, in order to prove these two triangles congruent, we really need another side length. So what's the third side of, say, like this first triangle here on the left? What's the third side?
LM.
Yeah, LM is the third side over here. What's the third side of the triangle on the right? LM. Can you prove that two sides are congruent to itself? Yeah. So LM is congruent to LM. Again, these are segments. And what is the reason for that? Okay, you can't just say reflexive. Property of congruence. It's property of congruence because we're using the congruence symbol here. So property of congruence. And we'll see that several times today. Lastly, since we have side, 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 we'll just use the proved line here. Triangle KLM is congruent to triangle NLM. And our reason is just going to be side, side, side congruence there. And we can just abbreviate SSS. Is that all right? Is that tough? No. I think these are a lot easier than the proofs we've done in the past because when you're using side, 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 you know, well, I got to prove this side, and what am I looking for next? Let's see. Oh, yeah, another side. So you can just literally look at the triangles and figure out, well, what am I missing? I'm missing the third side. Let's try to fill these in really quickly just so we can see. It gives us a piece of given information that AB is congruent to DC. Why is that? Given information. Then the second piece of information here, BC is congruent to AD. Given, so that's pretty straightforward. Thirdly, it talks about how AC is congruent to itself. Reflexive POC. Okay, and lastly, this triangle is congruent to this one. Why? Yes, side, side, side. Okay. That seems pretty straightforward. It seems like the exact same proof we did, just slightly different picture. What could they do differently if you're trying to find that some side is congruent to another side? How's another way that they could geometrically talk about that? Some side congruent to another side. Yeah.
Could they make two separate triangles?
They could make two separate triangles, yeah. And then you just have to find, I don't know how you find it. I don't know how you find stuff out about it. But.
Write it out.
They could give lengths of something, yeah. Another thing they could do is they could actually talk about the midpoint. So they could say, hey, D right here is the midpoint. Okay? It's not that tough, you're still kind of doing the same steps here. The first two steps are still just given statements here. So it's just a little bit different because then, well, how do you know that AD is congruent to DC? Yeah, so these two are congruent to each other. It told you midpoint, so it means you're going to use the definition of midpoint is your reason. It's a huge hint that if it just identifies, hey, this thing is a midpoint, generally speaking, your next step is going to be definition of midpoint. Later on, we'll see something we'll say, hey, these two things are right angles, and then you're going to use that same idea to prove the two things are right triangles. Basically, this step flows directly into the next step. It should be, once you see something like this, it should be an automatic response. Oh yeah, I better use definition of midpoint as my next step. Okay. So we had a side here, we had a side here. BD is congruent to itself. What's the reason for that? Right. I think we're really trying to pound this one to the ground. I hope that we are all realizing that one there. And then the two triangles are congruent by, well, the only reason we really know, side, side, side. Any questions on how this works? Is it really similar to what we just talked about? Do you feel comfortable with these? Sure. Okay, let's try something a little bit different then.
No.
Okay. A little bit different. Why is it different? Well, you have overlapping triangles. Okay? Look at what you're trying to prove. You're trying to prove triangle VWX. So VWX is kind of this right triangle up top here, kind of a big triangle, something like that. And then you're going to try proving it congruent to this other triangle, which looks like this. Okay? So we're trying to prove that blue is congruent to green, I guess. Sort of a neat deal. Okay? The first step, still your first reason, and I'd probably write this down. This is number 25 from your textbook. I'm not sure if the answer's in the back of the book or not. My book is different than your book. It does say the answer's in the back, but I don't know if it's a full answer or not. For your homework, also number 27 is pretty much identical. So maybe don't write everything down, but kind of write the general steps down so you kind of know what's going on. WX is congruent to BZ. Those are actually parts of the triangle. So this step right here, this actually gives us one side. Okay? And these next two are just pieces of kind of what I would call the hypotenuse. So we basically say this part, I don't even know how to draw this. This part right here is congruent to this part here. Well, that's not really a whole side. Then we get this part is congruent to this part here. What we're going to end up doing is we're going to have to talk about these not as segments, but as lengths. And we'll try to add the lengths together to find some way to get them together. And then we'll kind of say, well, by angle addition, or I'm sorry, segment addition, we can talk about that whole side being sort of like a hypotenuse. Okay? So this first statement here, maybe our second statement is we should get this other easy side over here, maybe we should talk about this side over here. I don't know if they use Roman numerals or not.
Yeah.
I don't know. So we're just going to say, hey, that's congruent to itself by reflexive POC. And honestly, if you write this as WV is congruent to WV, as long as there's a segments on top, I think that's okay. You don't need to reverse them like that. Sometimes the book does, and sometimes it doesn't. It doesn't bother me either way. Whichever way you write those should be fine.
Wouldn't that be this symmetrical property then?
Because it's in two different triangles.
Ah.
Okay, so either way you write those is totally fine. After that, what we're going to do is we're going to change these over from being congruent to just being equal to each other, so like actually lengths. Okay? So this length is equal to this length is equal to this one. That's just by the definition of congruent segments. Okay? So some length is equal to some length. It's basically taking step one, it's transforming it into this. I'm sorry. We had one side, and here are some lengths. And what we're going to do now, the next step is kind of a little bit tricky. Okay, it just takes a little bit of creativity. We're actually going to take this statement right here, and what we're going to do is we're going to add YZ to both sides. Okay, I'm just going to take this statement, I'm just going to add the exact same thing to both sides, which is called the addition property of equality. I'm just going to take it, I'm going to add them to both sides. The exact same thing to both sides. Okay, I'm going to tell you why here in just a second. Okay, so with this statement, here's the y, wy, here's the vy, and all of a sudden we just added this guy and this guy to both sides. Okay, so we added the exact same thing to both sides. And then because these guys are equal to one another, see how this guy is equal to that, what we're going to do in our picture, let's see, wy and yz, that makes sense. We're actually going to substitute this guy into here. Since these two are equal to each other, I'm just going to substitute this piece into here. So I have basically here's a complete hypotenuse, and once that's substituted in there, I'll have a complete hypotenuse again. So our next step will be substitution. I'd probably change the way I'd write it. I would not write property of equality. I'd go and say step number 3 into number 4. A lot of people will say in your proofs, I've noticed people say step number 5 a lot. Well, this is step number 5. You don't reference step number 5 as the reason for step number 5. You reference the things before it. So basically, I took number 3, I put it into number 4. That's how I got step number 5. So be careful with that. I've seen that done several times. Okay, so at this point, we're basically talking about some hypotenuse is congruent to some other hypotenuse. I call them hypotenuses because they look like right triangles. They're not necessarily. At this point, we're actually going to kind of add them together. We're actually going to use that segment addition, not to scroll down just a little bit. So we're actually just going to add these together. WY and YZ is basically going to be this entire length is WZ, and that's just segment addition postulate. And VY and YX are just going to equal VX. I think that's okay. Step 7, we're going to move from being equal to being congruent. So we're just going to say those things are congruent. And step 8, this just gives us a third side here. Step 7 gives us a third side by the definition of congruent segments. And step 8, those two triangles are congruent. Yes, ma'am.
Why don't we just keep it congruent through the whole thing?
You can't use the segment addition postulate for things that are actually segments. You can just use them for lengths. Okay, so it only talks about length. The only way we can add stuff together or add something to both sides is with the addition property of equality, I guess. You can't, there's no addition property of congruence. That's why. So everything needs to be converted. So all this conversion stuff in here is all just because we need to use the addition stuff. So it needs to be segments. Okay. So be careful. If there's a segment on top of it, those are going to be congruent. If there's not a segment on top of it, it's just talking about a length. Things you can add lengths. You can't add together segments. Good question. That was really good. What do you think, Paige?
Like the fruits.
Yep. What if something else hurts? Like, what if your face hurts because math hurt? Oh, it's so hard.
Oh no, I just have a headache.
Oh, Paige. Does anyone have any questions about this proof? Okay. So this is basically side, side, side. This is as complicated as you can really get. As I said, this is number 25 from your assignment. This is your assignment. This is one of the questions from your homework. 27 is really similar to it. The other two are really short that are right there. Yes, sir.
Could this be a test or closed question?
Could be. No idea. I don't think it's fair for me to tell. Number 4, section 4-6. We are doing 2 sections in one day. They're so similar that I was like, well, why don't I just do both sections? So here it is. Side angle side is the second way that you can prove triangles congruent. Okay, but it's very specific. See how the word angle is actually written in between the two sides? See how this A is physically between these two S's? The same thing happens when we look at the triangle. It's that the angle is physically in between the two sides. It's the two sides that actually make up that third angle. Again, here's your two sides, and it's physically the angle that's in between. If you were to look at my arm, I have an angle that's physically in between my forearm and my top part of my arm.
Bicep.
Well, that's the muscle, that's the tricep. So there's the top part of my arm with my bicep and tricep, and there's my forearm. Basically, the angle is my elbow that's in between. Okay? So it's actually the angle that's in between are made up of the two sides. Okay? That's what we're talking about. You couldn't all of a sudden start naming, hey, I want to use angle B up here. That'd be a side, and an angle away from. We're talking about physically having an angle in between. Okay, and here's sort of an example. Again, this statement is very specific, so be careful how you write it if you're writing it yourself. Okay? Are we all right with this? Okay. We'll look at a proof really quickly. It is proof heavy because that's really what the section's about. But again, they're going to be about 3 to 5 steps, most of them. Okay? So it tells us that side BC is congruent to side BA. So just these two sides are congruent. Then it tells us parallel. What should be our automatic response when we have two sides of something like this being parallel? What should be our response? Yeah, we're looking for angles. What type of angles? Alternate interior angles. So we're probably looking at this angle and this angle right here. Okay, so probably those two angles right there. And then maybe for our third piece, we could probably say, AC is congruent to itself, something like that. And that would give us a side right here, and the angle in between. Side right here, and the angle physically in between. Does that make sense?
Yeah.
Okay, so that's kind of my plan of attack as far as this goes. Let me erase this and see how the book does it, because I just want to show you how they do it. And they phrase things just a little bit differently, but that's kind of what I think about. So it tells me this. It tells me a second given line. So those things are parallel. If you want to write them on 2 lines, it's fine. I like to kind of write this S out front here and say, hey, I have a side going on. Then by the alternate interior angles theorem, I can prove some sort of angle. And there's an angle written out here. And then thirdly, by the reflexive property, I have this third side. So since I have side, angle, side, I can then prove the two triangles congruent by side, angle, side. Okay? Side, angle, side. Any questions on how that works? Okay? So you need a side, you need another side, and the angle that's physically in between those two sides. All right. Now, a lot of students say, well, can you pick any 3 letters? There's a lot of fun words that you could spell with the letters A, S, and whatever else. But basically the idea is that students try to say, well, can we just use the angle side postulate in order to try proving triangles congruent? And this is a discussion. This is actually physically from the book right here. This does not work, just so you know, where you have some angle and then 2 sides that are away from it. That doesn't work. Okay? There's a reason it doesn't work. It sounds dumb when you say it, for one thing. And secondly, it geometrically doesn't work either to have 2 sides away from each other. Okay? What this is trying to say is that you can actually create 2 different triangles. It's saying the length of BC and the length of BC are exactly the same, but we have 2 different triangles. There's an obtuse triangle over here on the right because of this angle here. There's an acute triangle here because of this angle. Even though they do have the same angle, and then 2 sides that are away from each other are congruent, you actually need a 4th piece of information in order to make these 2 triangles to prove that they are congruent. Okay? So it says it slightly differently. It says the SSA, because they want to be polite, is not a valid method for proving triangles congruent. Just kind of keep it in mind. But then it does say, well, there is a special case where this does work, and it only works for right triangles. The reason it works for right triangles is because they're right triangles, and there is a relationship between the sides and the angles in a right triangle. So it talks about how in a right triangle, if it's a right triangle, then these are called legs. There's usually like a short leg and a long leg, and there's going to be a hypotenuse, which is always across from the 90-degree angle. If that's the case, then you have this special 3rd property that we're talking about today called hypotenuse leg. We abbreviate HL. And it says 3 things you need to prove. You need to prove that you have right triangles, and then that the hypotenuse of one triangle is congruent to the hypotenuse of another one, and the leg of one is congruent to the leg of another triangle. Okay? So hypotenuse is always going to be the longest side. The legs, it doesn't matter. It's going to be the short one, the long one. But it needs to be in a right triangle. That's the hard part to prove that something is actually a right triangle. Okay? So even though it just says HL, you think, oh, I just need to prove hypotenuse and leg. You also need to prove that something's a right triangle. And that's the complicated part. It tells you it's a right triangle. You're a smooth sailing. Piece of cake. Cake. Like cake. Okay. So hypotenuse like. I'd probably write one of these down. Actually, this one's in your textbook. I think this is on page 240. So if you want to just write down page 240. I don't know what example this is, but it's one of the examples from the book. The idea is they'll give you, what example is it? Example 3? Okay, it's example 3. It says they'll give you two triangles like this, and sometimes they'll be overlapping, and this gets kind of confusing. Okay. Generally speaking, I had a teacher when I took this my freshman year of high school, and she said, you know, always write everything down. I think it's a good idea. She had us write down our given information. She had us write down the proof lines. She had us draw the picture every single time. I think it's a really good idea to draw the picture, but I would do this first. I would separate them into two triangles. I would not draw this, even though that's what they gave me. I would actually draw it as two separate triangles. Then I'd start marking it based on the information they gave me. Okay? So they told me this is what's going on, so I'm going to mark that. Oops, sorry, that's this one here, this one here. They told me this is perpendicular to this, and this is perpendicular to that, so I'd draw these right angles in here. And then in my brain, I'd be like, well, I can always prove that this thing is congruent to itself. And that's the part that students forget. When you do separate this into two triangles, you kind of sometimes forget that, oh yeah, that reflexive property of congruence says that's congruent to itself. So that's why when I draw them as two separate ones, I make sure to mark that right away. Okay. That also helps me with my plan of attack. That basically, if you look at this, if we can prove these are right triangles, there's a hypotenuse and there's a leg, two triangles are congruent. Okay? So let's look at how you prove things to be right triangles, because it didn't tell us they're right triangles. They just told us these are perpendicular to each other. Okay, so this is going to be a couple steps, just so you know. Well, you can see it part of the book. Okay, so it gives us the given information that gives us a hypotenuse. We know these things are perpendicular to each other. Next thing, by the definition of perpendicular lines, we can say these two are right angles. I don't like the way that they phrase this, angle Z and angle Y, because, well, why don't you mark this one being a right angle? That's angle Z, isn't it? And that's angle Y right there. Why don't you mark this one being a right angle? Okay? I think it would be better to actually write this out as WZY and XYZ, something like that, as opposed to writing it as just angle Z and angle Y. Okay? Because there are technically more than one angle Z, so I think the way that you write it, you got to be kind of careful with this. Okay? Because you have these as right angles, you can then say, hey, by the way, these are going to be right triangles. And why is that? Well, it's the definition of right triangles. That's what right triangles are. They have right angles. For some reason, there's no part of the definition of right triangles that says anything about 90 degrees, doesn't say anything about perpendicular. So the idea is, from these things being perpendicular, we can say, okay, well, perpendicular means right angles. Right angles mean right triangles. So every time we see this, there's actually going to be two more steps that are going to be basically the next two steps that follow. So always when you have perpendicular, talk about them being right angles. From right angles, talk about them being right triangles. Okay. From there, since they're right triangles, that's another important piece. The next thing we just have to do is reflexive property of congruence. That gives us a hypotenuse, our right triangles, and a leg. Look at them for the two triangles congruent by hypotenuse leg. Okay. So from step 2, we automatically have to do steps 3 and 4. That's just how these work. It's always how it works. Might be a good thing to note. Page 240, example number 3. Okay. Another one really similar to it. Again, you might separate this into two triangles. You got to be kind of careful how you do it so you get the right ones. There's tons of triangles in that picture. In fact, they don't even really need this little line here. I think that's kind of cool they put that in there. I think it's just to confuse people. Because we're going to be talking about basically now the top left triangle, the top right triangle. And you get that by looking at the proof line. What are we trying to prove is congruent? So, but again, it's really similar. QS is congruent to PR. So that's this. Ooh, I don't even know how to draw this. Something like this is congruent to PR, which is this hypotenuse, I guess. I don't even know how to mark that. I guess kind of like that. So that would give me a hypotenuse. And between this and this, we can talk about this being congruent to that, so it's going to help us to have right triangles. And lastly, we'll probably say, well, SR is congruent to itself, something like that. Okay. So again, given information, that gives us a hypotenuse. This is going to help us get our right triangles. From this, we say, hey, these are going to be right angles. So those two, again, I would spell these out to make sure that you know which angles you're actually talking about. And what's the reason for that? How do you go from being perpendicular to having right angles? What definition do we use?
Perpendicular.
Perpendicular lines, yeah. Definition of perpendicular lines. Okay, so the perpendicular lines give us right angles. Right angles should give us right triangles. So the way that we write this is I always write whatever the triangles are, however they're written in the approved line, like triangle PRS and triangle QSR are right triangles. That's the definition of right triangles. If they have right angles, they're right triangles. So from perpendicular to right angles to right triangles. From there, we're just going to talk about the, let's see, this thing's congruent to itself. Again, for like the fifth time, the reflexive property of congruence. And finally, since that's a hypotenuse and a leg, we can prove these two triangles congruent by hypotenuse and leg. Okay. I feel sometimes I'm beating a dead horse, but I want you to see some of these proofs enough. And the dead horse is not getting up. Like I'm just grabbing the crutch. I'm just beating the dead horse. And the idea is it's not a violence-free society, but the idea here is I want you to see not just one time. Sometimes you need to see a proof twice to be like, okay, well he's doing the same thing again. Okay, it's the same thing again. It's only by seeing patterns that you're going to be able to start recognizing those patterns and probably going to be able to do them yourself. Okay, your assignment is fairly. Well, it's only 23 problems long, but there are some proofs involved in it. Okay, there are technically two assignments here. There's this page here, which is just 4-4. There's this page here, which is the 4-5 stuff. This one's only 9 problems long. This one's only, well, whatever the other one was. I guess 14 problems long. They're not long assignments. A lot of them are. There's some odd problems mixed in here, like 5 and 11 and 21, 25 and 27 are odd ones. A whole bunch of odd ones here. There's a whole bunch of odd ones in here that I hope you guys can check and you can compare with each other and really learn and grow and all this other stuff. There are some proofs in here though, okay? And this section is all about proofs. Tomorrow's homework is going to really be all about the proofs. All the other stuff is just sort of setting up to make sure that you can do proofs. Okay? I want you to have more confidence with proofs. That's my goal, is to have more confidence with proofs. If you do, I think this world will be a happier place, and more children will laugh and play gleefully.